Hi, it's GA05, Raghad, Ren, and James, working on accommodation on Mars. Our main idea arises from the colossal temperature difference on ground level and 2 meters above ground level on Mars, referring to a state of the art illustrating where people will spend most of their time during day and night. We chose this sphere form for pressure differential matters and to minimize heat loss. We looked into some metaballs and immersed parts of them underground based on the most efficient use of energy and measured how hard the rock was and how much energy we can save, which basically resulted in our metaball accommodation with an interior courtyard cutout, along to connections connecting us to other programs on the master plan.
Now we're going to talk about our collaboration diagrams. This is our initial collaboration diagram for the master plan, showing that accommodation, which is our group, is interacting with almost all of the other groups. This next one is our first diagram, which showed just kind of the idea of where our flow of information would go. This is a revised version of that, where our blue lines are the speckle streams in between our team members, and then the white lines are the speckle branches within our own streams. So I had the connector, James had the shell, Raghad had the interiors. So we each had our structural analysis and our solar and wind. We came together to make sure everything was jiving. Then we broke it out into site plans, renderings, sections, detailing, schedules, and we'd share that off with our fellow classmates. I had my connector stream, which is pulling in information from our neighbors. We had small, medium, large connectors. We had the structural mesh, the panels, and the igloo entrances. Those all became commits. Raghad had interiors, which took in information from my connectors, took information from James's shells, and from the neighbors. Again, small, medium, large. We had floor plan curves. We had 3D B-reps and labels, which were text tags. And James had the shell, which took in information, again, from our neighbors and the master plan, small, medium, and large sizes. We had a drape mesh over everything. We had a solar analysis, some structural analysis. And our metaballs were above ground and below ground. And there was a central dome with some panels above all of that. And that was all committed together. Some of our collaboration problems were some branches had no commits. Sometimes we had communication issues. Are you there? Are you busy? Or unavailable for genuine reasons. The files that we had were sometimes shared on Google Drive, sometimes shared on Slack. Some files were made in Illustrator, so therefore that was not a speckle stream. Some of us were learning Revit and Grasshopper for the first time. So it was a lot to take in. And we still needed to share our Grasshopper files. What ended up happening in the class is we'd learn something, we'd do an exercise, we'd learn something, and we'd do an exercise. And then we decided, oh no, how do we figure this all out for Studio? What we might have wanted to do was learn something, do an exercise, use it in Studio. Learn something, do an exercise, use it in Studio. And we still had to have a non-speckle way to share our Grasshopper files.
Our app proposal is GH Cloud. Problem: architects all over the world are wasting time creating identical definitions in Grasshopper. Solution: make it easier for architects to share Grasshopper files that only need to be created once, an open and free library of the world's most commonly used files. Before 2000, architects used reference books with limited amount of information that went out of date quickly. That's why when Dublin opened their port tunnel, many of the newer and larger trucks couldn't fit inside. By 2010, firms had locally hosted digital folders of CAD blocks, Photoshop trees, and people. Cloud-based services emerged in the last few years, such as Dimensions.com, who provide a wider range and more organized collection of 2D drawings with every type of furniture from IKEA to Vitra. One reason to better organize files is for beginners who want simple files to help them understand the basics of Grasshopper. 2D curves using a surface morph from this tower project are difficult to create for some and a waste of time to create for others. That part can be shared as a hops component independent of the design. Similarly, files such as this car park don't need to be recreated by multiple people around the world. One of the other studio groups asked us, how are you draping a mesh over another mesh? So I shared a file that can be used as a hops component. GH Cloud proposes a large library of repetitive tasks that should be organized and hosted in the cloud. I wonder how many people download a plugin to use it once and never use that plugin again. The value GH Cloud provides is a place to learn and improve Grasshopper knowledge and efficiency for advanced users with the possibility of cloud computation for one-off tasks.